I'll say, okay, so we're going to graph quadratic functions. So first of all, understanding quadratic, first thing I understand is what the word quadratic actually means. And if we say quadratic, quadratic basically means a polynomial with an exponent squared, like y equals x squared. That's the highest exponent it has is x squared. So this is just a basic quadratic equation. The standard form for quadratic equation, standard form, is y equals to ax squared plus bx plus c, where a, b, and c are numbers. You have x squared and another x. So that would be standard form for a quadratic equation. What's also nice to know about the standard form is the a value here, it shouldn't equal to 0. So that symbol means not equal to. So a is not equal to 0. The reason why if a was 0, it'd be 0 times x squared, which makes it 0, meaning that this piece wouldn't be there. It would be an expression that's no longer quadratic. It'd be linear. So because of that, a has to be something other than 0. Something else to know about quadratics is they form a parabola. All right, so what a parabola is, it looks like this. This is U-looking thing when you graph it in a coordinate plane. So if you had some x-axis and y-axis and an x-axis, and you graphed it, you can graph this shape. Each one of those is called parabolas. And what's interesting about each of these parabolas is they each have a vertex. This is a vertex. This is a T here. So what's a vertex? Here's a vertex. And basically what they are either the lowest point, or in this case the highest point. That represents the vertex of that parabola. That would be an absolute max, that would be absolute minimum in that parabola. What's interesting about the vertex is if I actually graph a parabola like this one, I would have a line that would go straight down the middle of this parabola, and that line must go through the vertex. And this line has a name as well. That line that goes down the middle of that parabola has a name, and it's called the Axis of Symmetry. So this line is called the Axis of Symmetry. You already may know some stuff about the Axis of Symmetry. You think about it, it says symmetry. And basically what that means is if I looked at this line as a vertical line and I thought about this whole picture as a sheet of paper, and I could take this sheet of paper and if I could fold a crease right down this vertical line, everything on this side should lie on top of everything on this side. There should be a mirror image about that line. So that's why we call it Axis of Symmetry. Just so you know, a really great way of finding axis of symmetry, once you find the vertex, the coordinate for it, as in x, y coordinate for it, axis of symmetry, it's going to be x coordinate. Basically x equals whatever that number is. For the x coordinate of the vertex, that's always the number that represents the axis of symmetry. And the axis of symmetry is written as x equals that number, whatever that number is. Because when x equals, you know that's a vertical line on a number line or on a graph. So that's why it's called axis of symmetry, and that's just what it is. All right, so right now what you should do is actually pause the video, write down anything that you might consider a pretty good note, whatever you didn't know already or whatever, and after you finish writing everything else, unpause the video, because I'm about to erase all this stuff, and you can continue from there. So right now, just pause the video and get down anything you need to get down, and then unpause it, and you'll see new things on the board. All right, so again, pause the video and take notes. All right, suppose the direction said graph this function, y equals to x squared plus 4x subtract 5. You may notice right away, this is a quadratic function. Why? Because it has x squared, it's the highest exponent there. So it makes it automatically a quadratic function. So if that's understood, if you didn't know what else to do, and you had to graph this, you start off with x and y axis. And if you know nothing about what I'm about to tell you now, you know absolutely nothing, the best way you can always graph any function, whether it be quadratic or whatever else, is simply create a table of values. And you make up your own values for the input. Here the input would be x. So you make your own values for x, plug them in, and then graph them. Now, if you plug in crazy numbers like 500, whatever, you can get really, really huge numbers here. And it's really hard to graph on a number line. So consider it probably starts around 0. So you probably want to choose numbers that are reasonable, somewhere in between 0 and 10, or better yet, in between -10 and 10. And even then, sometimes the number can get really big, like -55 or whatever, or +55. So that just tells you either you can graph it that high, or you can choose a smaller number, or a number closer to 0, and see if you get something a little bit smaller, or a little bit lower down. So I'm just going to choose, I don't know what this graph is going to look like, so I'm just going to make up some numbers. Some good, easy numbers to work with are numbers like 1. Well, let's start with -1. And then 0, and then 1. And that's might be enough. And if we don't see enough to see a graph, I'll keep coming up with some more numbers until I actually see a curve. So just to be sure, I'm going to mix some other random numbers up. -3 and -4. And you can plot these numbers. How would you plot them? Where it says x is -1, what is the output for y? So you take -1, you plug it into this equation. So that would be y equals to -1 squared plus 4 times -1 subtract 5. And you would now see that that's equal to 1 subtract 4 is actually it's +1 subtract 4, so that's 1 subtract 4 subtract 5. It's -3 subtract 5, -8. So at -1 output's -8. And then the next number down is 0. What is the output at 0? So I'll plug in 0. Y equals to 0 squared plus 4 times 0 subtract 5. Well, at 0, you're going to find that the output is simply, this goes away, that goes away, -5. So at 0 is -5. And we can keep going. Plug in 1. So that would be 1 squared plus 4 times 1 subtract 5. At 1, you should find that the output is 0. If you check it out, you should get 0. Then you can plug in -3, exact same way. I'm running out of space here, so I'm going to erase some of this stuff. Or better yet, you just plug in -3. Pause the video, and plug in -3, plug in -4. So right now, pause the video, plug in -3 and -4. Tell me what you get. See if it actually matches mine. So yeah, go ahead, pause it now. Tell me what you come up with. -3, I got -8. At -4, I have -5. So those are the points I actually have there. You're going to check this out again. Actually at yeah, that's true. All those are true. So I'm going to plot each one of those points. Each one of those are ordered pairs. All right, so this is ordered pair, -1, -8. So come over here and put some numbers on this graph. I'm going to actually plot all those points. All right, so let's plot these points. The first one, -1, -8. Well, -1, -8's about right here. The next one is at 0, 5, so 0 for x and -5 for y, be about right there. At 1, 0, you go over 1 and up 0, roughly here. At -3, 8 would be over around -3, and then you also go down to -8. There was a negative sign there on that 8. And the last one I have is -4, 5, -4, -5. Which is around right here. So you see a good picture of what this graph looks like. I know it's parabola, but I don't really know how far it goes down. So I know it goes down somewhere beneath there. So I know I got a good picture of what this graph is doing, but to go ahead and find out, I'll figure out what my output is at -2. So I'll plot one more point to see if I can find my vertex. So I plug in -2. When I plug in -2, I get an output that says y has to be -9, which is great. So I know at -2, my output's -9, which probably around here. And I see enough to know my graph does this. It goes down through these points, comes back up through these points. And that would be the graph for it. And we have an intercept here where it crosses right there at that line. And if this is my vertex, chances are this is my axis of symmetry right here at -2. I could prove it a lot of other ways. That would be my axis of symmetry. So I know that since everything's symmetric, I know to get to this point, I'll go over 1, 2, 3 units. So technically, I know to find another point, instead of giving a sketch of what that is, I could truthfully figure it out. Like I know on this side, it's got to be, if this is 3 units away, well, how far it has to be away to the left? Well, yeah, it's got to be 3. So if I count over 1, 2, 3 units, I know it really goes through that point right there. And that would be true for any of these points. They're going to be the same distance from the axis of symmetry. So anyway, that's the most basic way that you can graph a parabola. I'm going to give you some algebraic ways of graphing it, but when in doubt, you can always just plug in numbers until you actually see the curve for it. Oh, I'll give this as a note. I'm about to erase it now. So give it a new example. So let's graph the equation y equals 2x squared plus 8x subtract 4. If you're going to graph it, you need 2 things. First, find the vertex. After you find the vertex, find several points to the left and to the right of the vertex. So first find the vertex, and then find several points to the left and right of the vertex. How do you find the vertex? The vertex is written by this formula. Negative b over 2a gives you x coordinate, and then f of negative b over 2a gives you the y coordinate. So the vertex would be x and y value. Sometimes I can see vertex written as h and k. We'll talk about the significance of h and k in just a minute. But basically how you find the vertex is you use negative b over 2a, and then you plug in f of negative b over 2a to find a y coordinate. What is negative b over 2a? Awesome question. If you notice, this is the a value. This is the b value. This is the c value. It's in standard form. If you remember, the standard form for a parabola was, or quadratic was, ax squared plus bx plus c. So this would be c, this would be b, and this would be a. So c is a negative 10. So pause right now and actually figure out negative b over 2a. So negative b over 2a, b is 8, a is 2. So it's negative 8 all over 2 times 2, which is negative 8 over 4, which is negative 2. So now the x coordinate of the vertex is negative 2. F of this means take this value and stick it in for all the x's. So basically, f of x, or f of anything, basically means y. So that means this means f of x of all of that. Or in this case, f of negative 2. So what I want is f of negative 2. You're going to plug in negative 2 everywhere. 2 times negative 2, everywhere there's an x. 8 times negative 2, subtract 10. So everywhere there was an x, you're going to place that x with negative 2. You'll find the value of that. And the value of that should be negative 18. So I know that coordinate for the vertex, my vertex, is equal to negative 2, negative 18. So let's begin by plotting that. And then after, he's going to find several points to the left and right of that vertex. Let's do that now. Oh, and I will be erasing this, so if there's anything you need there, you may want to write it now. All right, so these are counted by 1s. I'm going to make sure to count these by 2s. This is negative 4. That'll be 2, 4, 6. This will be 8, 10, 12, and so forth, because the numbers get pretty big. All right, so vertex at negative 2, negative 18. These are counted by 1s, and these counted by 2s. So negative 2, negative 18 would be here. That would be my lowest point on this graph. Just so you know, if that a value is positive, parabola opens upward. If a is negative, it goes downward. It's a nice little thing to know about. All right, now I want to choose some points to the right and to the left of this graph. For example, maybe 0 and 1, and now I know enough to get an idea what that graph is doing. So I'll plug in 0 into this equation, output's negative 10. I'm plugging 1 to that equation. I'm sorry, yeah, 1 to that. I'll plug in 1 into that equation. Output is at 0. So at 0, at 1 I got an output of 0. At 0 I got an output of negative 10, which is here. I know this is symmetric about this line. So technically, if this is here, I know there's another point that has to be directly to the right of it, here. And another point has to be 2 steps to the right of it, here. It gives enough information to know the curve does this. It goes down through these points and back up I wish I made that smoother. But that's it. Good luck.